In this video, we'll look at composite functions. I've created a list of 2 points. F at x is -1, 4, 3, 5, 4, 7, and 5, 0. And g at x is 0, 1, 3, 4, 4, -2, and 6, -9. There's a bunch of questions here to do. The first says evaluate f at g at 3. So order of operations, we leave the f part alone, and we're just going to evaluate what's g at 3. It's as simple as going to your list of points, looking for x value of 3. When you sub in 3 to this equation, what y value do you get? 4. Let me say that again. What's g at 3? It's what y value do you get when g's x is 3? You get a 4. So put a 4 there. And now you do the same thing for f. Looking at these points, when you sub in 4 here, what's f at 4? What's the y value when f's x is 4? It's 7. So f at g at 3 equals f at 4, which equals to 7. Let's do the next one. Leave the outside thing for now. It's g at f at 5. But first we have to figure out what's f at 5. Go to the f function, look for 5, and f at 5, its y value is 0. And now we sub into g. What's g at 0? G at 0 gives a y value of 1. So g at f at 5 is the value of g at 0, which equals to 1. Try another one. F at g at 4. Leave the outside function for now and evaluate the inside function, which g at 4. G at 4 gives -2. And now what's f at -2? There is none. Well, that's important then to mention that this whole quantity is undefined. That is, we tried to evaluate f at g at 4, and we got that's the same as f at -2, because that's what g at 4 was, but there is no -2 for f at x. Therefore, this answer is undefined. There's no point defined for f at g at 4. Similarly, let's look at this one. G at f at 2. Go up to f at x and look for a value of 2. Once again, there is none. So we have no work to show. We say this point as well is undefined. Does not exist. What happens when you have equations? I put a line here to separate my work. How about f dot g at x? That's like saying f at g at x. This dot means sub in g into f. So I put the g at x function inside the f at x function, which equals, I'm going to start with the outside f at x function. It's 2x squared plus 5. And then I sub in the g at x function, which is this, into f at x. Let's see that again. F dot g at x is f at g at x. So take g at x, which is x minus 1, and sub it into f at x. So I wrote the outer f at x shell, but in place of the x, I put g at x. That's how I got that equation. You could expand and simplify, but there's no need to. The next question is just evaluate f dot g at 2, or f at g at 2, which is just f at g at 2. But you don't even have to write that. We already know what f dot g at x is. We can just sub in 2 brackets 2 minus 1 squared plus 5. And now evaluate. That's the same as 2 times, what's 2 take away 1? 1. What's 1 squared? 1. And we get 2 times 1 is 2 plus 5 is 7. Oh, we found f at g at 2 by using our equation f at g at x and subbing in 2 and solving. Works the same way if you go the other way, g dot f at x, except this time g is on the outside and f at x gets subbed into the inside. What I mean is take g at x, which is x minus 1, so I'm going to write that down. X is this whole bracket thing, minus 1, but into this x sub in f at x. So replace this x with 2x squared plus 5. And you don't have to simplify it, but you might as well here. 2x squared plus 5 minus 1 is just 2x squared plus 4. And now, how do you evaluate g dot f at 2? you just sub 2 into this equation. 2 times 2 squared plus 4. What's 2 times 2 squared plus 4? Well, that's just 2 squared is 4 times 2 is 8, so you get 8 plus 4. And what's 8 plus 4? 12. And we're done. We've done composite functions where we used points and we found the value of f at g at x, or tried sometimes g at f at x, and we did it when it was equations. We found f at g at x or g at f at x, and we found a value at a particular x value.